Welcome to The Explainer. Today we are going to break down one of the most intuitive and, honestly, one of the most relatable algorithms out there in machine learning. It's called K-nearest neighbors, and it's all built on a super simple idea you already know. You can be judged by the company you keep. So let's start with something you've probably wondered about. How does Spotify just know what your next favorite song is going to be? Or how does Netflix nail that perfect movie recommendation? It can feel kind of like magic, right? Well, behind the curtain, it's not magic, it's just some really clever math. Yeah, the big secret is an idea we all get. Birds of a feather flock together, right? It's the same exact thing with data. The algorithm basically assumes that any new, unknown thing is probably a lot like the things that are closest to it. All right, section 1. To really wrap our heads around this, let's call it something a little more fun. The nosy neighbor algorithm. I mean, that's really what it's doing, peeking over the fence to see what everyone else is up to figure out where you fit in. Okay, so the official name is K-nearest neighbors, or KNN for short. Now, you'll hear it called a supervised algorithm. All that means is we have to give it a bunch of examples that are already labeled, so it knows what it's looking at. And here's a cool part. It's also called a lazy learner. Why? Because it doesn't do a ton of work up front. It literally just stores all the data you give it and only does the hard work of calculating things when it's time to make a prediction. Okay, section 2. What's the K? That letter K isn't just there to look good. It's actually the most important decision you have to make when you're using this thing. So K is just a number. It's the number of neighbors the algorithm is going to ask before it makes up its mind. It's kind of like you're trying to decide on a restaurant. Are you going to ask just your one best friend, or are you going to text your top 5 friends for their opinion? That number you choose, that's your K. And once it has its K neighbors, it's just a simple vote. It's pure democracy. So if you set K to 3 and 2 of your closest neighbors are, say, apples, and 1 is a banana, well, apple gets 2 votes, banana gets 1. Guess who wins? The algorithm votes for apple. Majority rules. Now, this is where it gets interesting, because picking the right K is a total balancing act. If you pick a really small K, like just 1, your prediction can be super sensitive. I mean, what if that one closest neighbor is just weird? It could throw the whole thing off. But if you pick a huge K, like asking the entire town, you might smooth things out too much and miss the important little details. You get the general vibe, sure, but you lose what's unique about your little corner of the world. So you're probably asking, how do I pick the right K without just guessing? Well, data scientists have a few tricks up their sleeves. A super simple one is to always use an odd number for K. Why? To avoid ties. Smart, right? And for more serious work, they use techniques like cross-validation or something called the elbow method to basically test out a bunch of different K values and see which one gives the best results. All right, section 3, measuring closeness. So we've been saying close and nearest a lot, but how does a computer actually measure closeness? It doesn't have eyes. How does it know what's near and what's far? Well, it all comes down to math, specifically something called distance metrics. These are just formulas, that's all. They take 2 data points and spit out a single number that says how similar or different they are. And the most famous one, the one you probably learned about in school, is Euclidean distance. It's the most straightforward way to measure distance, just a straight line between 2 points. You know the phrase, as the crow flies? That's exactly what this is. But what if you can't just fly in a straight line? What if you're stuck in a city grid? That's where Manhattan distance comes in. And yeah, it's named after Manhattan for a reason. It measures distance like a taxi would have to travel, only making right-angle turns block by block to get from point A to point B. Okay, let's move on to section 4, the 4-step prediction. We've got our K, we've got our way to measure distance, so let's put it all together and actually watch this thing make a prediction. It's surprisingly simple, just 4 steps. So here's the recipe. Step 1, you pick K, your magic number of neighbors. Step 2, the algorithm gets to work. It calculates the distance from your new point to every other point in the dataset, no exceptions. Step 3, it finds the K closest neighbors, the ones with the shortest distances. And finally, step 4, the neighbors vote. Whatever category gets the most votes wins. And that's it. That's the whole process. Okay, let's actually see this in action. Imagine we have a bunch of data points that fall into 2 categories. We've got blue squares and we've got red diamonds. Now, suddenly, a new mystery point shows up, this green circle. We have no idea what it is. So our mission is to classify it. Let's decide to use a K of 5. All right, the algorithm fires up. It starts by measuring the distance from our little green circle to every single blue square and every single red diamond. It's a brute force approach. It checks them all. And after all that math, it sorts them and finds the 5 closest ones. And here's what it found. In that inner circle of 5 closest neighbors, we have 3 blue squares and 2 red diamonds. So now it's time to count the votes. And the winner is the blue squares. With a majority vote of 3-2, the algorithm makes its decision. Our new green circle is officially classified as a blue square. And boom, that's it. That's the entire prediction from start to finish. Okay, Section 5, KNN in the real world. Now, I know we've just been talking about colored shapes, and it might seem a little abstract, but trust me, you're using things powered by this exact logic pretty much every single day. Think about it. Those recommendation systems on Netflix or Spotify, they're looking for neighbors, other users who have tastes close to yours, to suggest what you might like next. Or spam detection in your email. An incoming email is classified as spam if it looks really close to millions of other emails we already know are spam. It's working behind the scenes everywhere. So let's break down the good and the bad. The biggest advantage of KNN is how simple it is. It just makes sense, right? It's easy to explain and easy to build. But there's a catch. Because it has to compare a new point to every other point, it can get really, really slow if you have a massive data set. It also doesn't love it when there are too many features, what we call the curse of dimensionality. I mean, finding your neighbors is easy when you only care about your street, but it's a lot harder when you have to consider 100 different factors. Which brings us to a final interesting question. KNN is simple, it's powerful, and it's absolutely everywhere. But in a world that's getting more and more obsessed with super complex AI and deep neural networks, is simple still smart enough? It's a great reminder that sometimes the most elegant solutions are based on ideas we've all understood all along.